Okay, we should be recording. Good afternoon to the two students who were able to join. Thank you very much. It is,
sir.
yes.
You're welcome, sir.
It is 1 o'clock, so we may begin right now.
Hi, sir. This is Ariane and Ariel, mommy. Ariane is here with Ariel, so they're together here using one account because Ariane's phone is not working.
I see.
Yeah, so they're sharing. They're both on here right now.
Very well.
Thank you.
See. Thank you very much. And I see that Mr. Deo-chan has joined us. So thank you to the 5 students who were able to join. Since it is about 1 o'clock, we may start. So last week, we talked a little bit about units after we discussed a bit on multiplying and dividing fractions. So with units, we talked about, in our examples, centimeters, meters, and kilometers. Look up a little better. And we saw that each prefix in front of centimeters and kilometers, each had its own meaning as to what the unit of measurement represented. So a centimeter, we saw, because centi means 100, that there are 100 centimeters in meters. We know that, we also said that kilometers, the prefix kilo, means 1,000, and that there are 1,000 meters in a kilometer. And this is what we use as our example. We can apply this to meters. And we also said later on that we could apply this to grams, whereas meters describe a measurement of length, and grams describes a unit of mass, or you could say weight. I'd like to quickly make a note that later on in more complicated classes, mass is not the same as weight. Mass is saying how much of something you have, but weight is saying how much it weighs under a certain gravity. But for the time being, you don't have to worry about this at all. So we talked about saying there were 100 centimeters in a meter, and there are 1,000 meters in a kilometer. So one little chart that we were able to draw similar to this is the reason why I am showing you this. Are you able to see well what I'm writing?
Excuse me, sir.
Yes.
Can you please write a little bigger?
Yes, I was just asking about that.
Thank you.
Yeah, I think my marker is a bit bad too. So we can draw a small chart involving meters to saying that um, 1 meter, which we put at the center of this chart. Does this look better?
Yes, sir, it's better.
Okay, good. With meter in the center of our small chart, 1 meter is equal to 1/1000th of a kilometer, because there are 1,000 meters in a kilometer, and 1 meter is also equal to 100 centimeters. And the reason why I'm teaching you this or showing you this is because later on, when we talk about geometry and later on your more complicated fields of expertise, relating things to a central unit of measurement such as meter will be important when you have to convert certain measurements to other forms of measurement. So for example, if you were to I'm sorry. Design a bridge that is 1/2 kilometer long, a very long bridge. Then you would have to convert it into meters to design the building for parts. So 0.5 kilometers would be, because we know that there are 1,000 meters in a kilometer and 0.5 is equal to 1/2, we can divide 1,000 by 2. So we know that there are 500 meters in a kilometer. Miss Alicia. Good afternoon. We were just talking about our meter, our units, saying that we know that there are 100 centimeters in a meter and there are 1,000 meters in a kilometer. We drew a chart and we have an example saying if we were to design a bridge that was 0.5 kilometers long, which is 500 meters, we would convert it so that we know what to use parts. So let's say we had to build a bridge out of tiles that were 1 meter long, or no, that were 2.5 meters long. We would take the distance of the bridge, which is 500 meters, and we would divide it by 2.5, which is the length of the tiles, and we could say that there are 200 tiles that we need to use to build across the bridge. Does that example make sense to you? Anybody?
Yes, sir.
Yes, sir.
Okay. Any questions about what we just talked about?
No, sir.
No, sir. No,
Perfect.
sir.
Perfect. So let's extend this idea to weight or mass. Let's say that you had a suitcase that could contain 1 kilogram of weight. And you have, let's say you're packing clothes, and we know that each of your clothes is roughly equal to 3 grams. Now, in our example, we cited that our suitcase can hold 1 kilogram. Can someone tell me if they can probably tell what 1 kilogram is equal to? Let's break it down. Starting
Sir,
with,
can it be 10 grams?
can you repeat that, please?
Can that be 10 grams?
So you're on the right track. You were saying that we know we have a prefix and that our unit of measurement is grams because we have the prefix in front of grams. Do we know what do we know what the prefix kilo is?
I'm not sure about that, sir. Could it be 10 or 1,000?
There you go, it's 1,000 because as we cited up here, we have our prefix centi meaning 100, and we have a prefix of kilo meaning 1,000. Okay. Is this clear? Everybody can read this all right?
Yes, sir.
Yes.
Okay. So similarly, back to our chart here, we could take meter and we could replace it with gram. And it would be the same, calculation. Yes?
Oh no. Ma! Okay, wait.
Okay. So the purpose of the prefix is that the prefixes centi and kilo mean 100 and 1,000, and any measurement that you put, such as gram or meters, will mean the same thing. So a kilogram would be 1,000 grams, and 1 gram would be 100 centigrams. But when you use grams, you tend to just use gram and kilogram. Now, if we go back to our example, let's break it down. We said that 1 kilogram is 1,000 grams. Could I have perhaps Mr. Deo-chan tell us how we would solve this problem? So if our suitcase can hold 1 kilogram and we want to pack as many shirts as we can, and each shirt is 3 grams, how would we solve this problem? Mr. Deo-chan, could you start us off?
Could it go 3 into 1,000, sir?
It would be.
Yes. So because we have our equal units of grams and grams, we could solve this problem by saying 1,000 grams divided by 3 grams is our answer. So this would round out to about 333 shirts. Technically, the number would be 0.33 repeating, but 0.3 of a shirt is not a shirt. So we would just say 333 shirts. Any questions?
No, sir.
No, sir.
No, sir.
So with what we have here, I'm going to actually send you guys a chart later on that shows you all the different kinds of prefixes and stuff. You don't have to learn them. You just have to remember kilo and centi. These units of what we were just describing are going to directly relate into what we're going to go to next, which is geometry. Could you guys tell me how much of geometry you know about? Like you know about shapes such as circles and squares and triangles?
Sir, regular and irregular shapes.
Okay. Sure. I haven't called them regular shapes in a while. So geometry, if we look at the word geometry, just as a way of looking at it, sorry. Miss Marks, glad to have you join us. We just talked a little bit about units, which I'll get back to later. So with geometry, just as a very quick instruction, we have the prefix geo, meaning earth, and metry to relate to the word metric, which is essentially measurement. So geometry refers to measuring essentially the earth. So measuring like everything around us and measuring the planet itself. And people use geometry to tell that the earth was round back in the Greek times. So this will be all about shapes. Now, Mr. Aryan has said that you guys might have learned about regular and irregular shapes. Can I have an example of a regular shape or multiple shapes?
Geometry.
Sorry?
Can it be a triangle or square, sir?
Yes. So irregular shapes are your basic shapes, such as squares, circles, and triangles. Irregular shapes refer to other less perfect kind of shapes. Could maybe I have an example of some irregular kind of shapes?
Sir, can it be hexagon?
Hexagons can be a regular shape.
A circle, sir.
A circle is regular, typically.
Sir, half of a circle?
Seriously?
So you're kind of on the right track. So a half circle would be somewhat more of a regular shape because a regular shape simply refers to it being symmetrical. Are you guys able to see me well? Because I seem to be having one or two issues. Can everybody see me and hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, just making sure. So a regular shape a good way to think about it is a regular shape is what you would regularly think of when you think of a shape. So when you think of a square or no, if you think of a circle, you're thinking you're gonna, no, I can't draw circles. I'll go back to squares. If you think of a square, you think of a nice, perfect square with all equal sides. So that's the perfect kind of square. An irregular shape would be a really weird looking shape. That's not very symmetrical and it doesn't look good. So these are the regular shapes that you're going to be using most of the time. Regular shape is simply when the shape is symmetric and the sides are perfect. So a square is a regular shape because all sides are the same. A circle is a regular shape because it's a perfect circle. It looks the same on all sides. A triangle would be a perfect shape as long as all three sides are equal to each other. And a hexagon is a regular shape if all of its sides are equal. A half a circle would, I think it would technically not be regular. I think Mr. Aryan is right, but a half circle is still very symmetrical around its center and vertically. Is this a shape?
I don't think so, sir.
Okay. Well, let's look up the exact definition of shape. So a shape refers to the outline of an area or a figure. In terms of math, a shape would be defined as a 2D object and the shape would have to be closed. Does everybody know what 2D is?
Yes, sir.
Okay, nobody doesn't. So 2D means flat. So it's flat on this whiteboard, and closed means that there are no openings in the shape. So if it looked like this, it would not be a shape, but because it is closed, this is technically a shape, just a really nasty one.
Okay.
So the purpose of geometry, well, one of the purposes is that we can look at this shape and we can use other shapes to figure out what, how big this shape is or how long it is. and we'll talk about that in just a second. So we know that a shape can be anything as long as it's flat and it's closed. Does everybody know what area is?
Yes, sir.
Yes, sir.
Okay. So if everybody knows what area is, can I have somebody say what it is?
Length plus area equals length times width.
Okay. So length times width. So if everybody remembers, length, always have a problem with writing. So length and width refer to a square. So you have your square, you would have the length, and you would have the width. Or you could apply this to a rectangle. Length and width. So length times width says that if you multiply the length of the shape by the width of the shape, then you will get the area. So what area is, in this context, length times width, it's how much this shaded region is. It's how big it is. So if you had a flat surface, you would say, like this, whiteboard, you would say, how much of the whiteboard does this take up? And that's what you would use area for, because you can say area is how much space this takes up on the whiteboard. And if you find the area of the whole whiteboard, you can say that this area is a certain amount of the whiteboard's area. Now, when we said that area is length times width, this refers to a square or a rectangle. Can anybody tell me what is an area? How do we do area if we have, let's say, a circle? When we said area is length times width, we could see that a square or a rectangle has two sides. And since they are symmetrical in the way they are, we can multiply the sides together to find the area. Does a circle have sides? Miss Alicia, does a circle have sides?
No, sir.
No.
I don't think so.
So Miss Alicia, if the circle doesn't have sides, does that mean that we can find the circle's area by length times width?
I don't know, sir.
That's fine. So because the circle doesn't have sides, we cannot find its area by length times width. So area does not mean length times width, but length times width can be used to find area of a square. Let's think about why that works before we tackle the circle. So area is measured well, I'll ask you first. Does anybody know how area is measured? Okay. So area is measured in, most of the times we use square centimeters, at least in math class. So square centimeters is how we measure area. So we could say just a square centimeter, or 4 square centimeters, or 5.5 square centimeters. And you have to write it like this. Does everybody know what this is? Anybody not know what this is?
Square.
unit.
A square unit.
Square, yes.
Square unit.
So it's called squared because if everybody remembers, squared means a number times itself. So 1 times 1 would be 1 squared. A centimeter squared, or as we would call it, a square centimeter, means that it is 1 centimeter by 1 centimeter. So when we say it's squared, it's literally square. So one side would be 1 centimeter and the other side would be another centimeter. So the area of this square centimeter would be a centimeter squared. This is very important because this is how we measure area. We say that if we go back to this nasty shape, if we want to calculate how, what its area is, we would put it in terms of square centimeters if the unit is appropriate. So if we said that this had an area of 7 square centimeters, then that means you could fit 7 square centimeters in this shape perfectly. Let's just say that was perfect. But this is how we measure area. And if we were to say that this whiteboard had an area of 2,000 square centimeters, that means I could take a centimeter block and I could fit 2,000 of them on the surface of this whiteboard. Does anybody have any questions?
No, sir.
Okay.
No, sir.
Okay.
No, sir.
Now, if we have a square, or no, let's go to a rectangle. If this square is 2 centimeters by 7 centimeters, that means that this side of the rectangle can fit 1 centimeter here and 1 centimeter here, whilst this side can fit 1, 2, 3, 4, 5, 7 centimeters. Okay, so this is 1, 2, 3, 4, 5, 6, 7 centimeters on this side and 1, 2 centimeters on this side. It's not to scale, so so they look a little different in size. But the way that we find the area with a rectangle, we said was length times width. The reason why is because we can fit, pretend these are each squares, we can fit perfectly 14 square centimeters in this. So because each side is symmetrical, we can fit squares in a rectangle or a square really nicely. Think of it like a chocolate bar where it's cut up into little sections. That's how area works with square centimeters. Any questions?
No, sir.
Okay. So we figured out how area works and how we measure area. Let's go back to the circle. Does anybody know how to find the area of a circle?
The
Okay.
area of this.
Yes?
The area of the circle equals pi R2.
Pi r squared.
Square, yeah.
Mhm. Does anybody not understand pi or r? Okay. So the way we know that we can use length times width to find a square is because they are so symmetrical, and we can stack a bunch of squares inside of it. The way we understand how to find the area of a circle is that even though it is vertical and horizontal symmetrical, a circle doesn't have any sides. So we could never fit a square really nicely into it. Because it's always a bunch of curves, that means the area is going to look really weird. How we do know to find the area is that the circle is symmetrical in a radius. So we can take the radius and we can spin it all around the circle and it's equal. That's how a circle works. So it's like a clock where the hands of the clock move around the circle. We can basically do that with a radius. And that's why we are using a radius, and pi comes in, which, does anybody know what pi is equal to?
It's equal to 22/7.
Close, but not quite. 22/7 is an estimation. Pi, the only way we can truly write it is the circumference divided by the diameter. I know I wrote that small, but just remember that's the circumference. So when we say it's pi r squared, we are describing that we are taking the radius and we are moving it around the circle for how long the circle is, essentially. Now I want you to pay attention to the square. So I want you to pay attention to the square. If you just came back, we're talking about how we find the area of a circle. So I want you to pay attention to the square because area refers to the square centimeter. Because the shape is two-dimensional, this radius, which tells us essentially how big the circle is, has to be squared when we find the area, because the area refers to square centimeters, such that there is 1 centimeter side that points up and down, so it's vertical, and horizontal centimeters, and these are our dimensions. Back when I said that a shape is 2D, that means that the shape points vertically and it points horizontally. So the circle goes up and it goes to the side. Any questions?
No, sir.
Okay.
No, sir.
So we have our area here that describes how to find the area of the circle. So if we said that the length of r was 7, that means the answer would be 49 pi. You guys should be used to this. Now, and other times, there are curves that we cannot describe using circles. But circles are still very important. Does anybody know what this shape would be called?
Sir, an oval? An oval.
Okay, an oval. Correct. So everybody calls this an oval. which you can do. But in math, if you want to be technical, this would be called an ellipse. Now, you guys are not expected to have to do much with an ellipse until later on in advanced math. Like the math I'm in currently, people still don't know how to do ellipse a lot of the times. Now, what do we know about an ellipse? Let's say this was a regular shape. Not regular. Let's say that this was a very symmetrical shape. Could you tell me anything about an oval? Okay, that's fine. Miss Ariel, I believe you're there. Could you tell me, is an oval a shape?
Yes, sir.
Okay, so we know an oval. Ooh. We know an oval is a shape, and we know that a shape is 2D, and the line is closed. So we know that an oval is a shape. Now, does the oval have straight lines or does it have curves?
It has curves, sir.
Curves. So since it has curves and it doesn't have flat lines on it, does it have any sides?
Not sure, sir. I think so.
Well, technically because it's curves and it doesn't have flat lines on it, it technically doesn't have sides. So if any of you didn't formally learn this, a side in a shape refers to a flat line on the side of it. So a square, because it has 4 flat lines on the outside, it has 4 sides. Since a triangle has 3 flat lines, it has 3 sides. And since a hexagon, which may I remind you, we have another prefix, hexagon. Hex means 6, so it has 6 flat sides. So we know that an oval has is 2D because it's a shape, and we know that an oval has curves. And since an oval is only curves, it has no flat lines, it doesn't have sides. Now, finding the area of an oval is complicated because you have to know how high an oval is, and you have to know how long an oval is. And you will have your answer, essentially. Is an oval similar to a circle?
No.
No, sir.
Okay, it was probably a bad question. So an oval is not a circle, but it is.
has one similarity.
Yes?
It's kind of similar. They both have curved lines.
Okay, I'll take it. An oval is curved and it's round. So an oval is a little similar to a circle. So what I'm getting at is that when you have a shape, such as an oval, for example, where it looks kind of like a circle, but it's like a stretched out circle, because it's not quite a circle, but it's similar, we will use elements of a circle to understand how an ellipse works. And later on in math, when you learn how to write an ellipse as an equation, the equation will look similar to a circle. So that's kind of the idea I want to get across. So we talked about area, and we know how to do area. Well, we reviewed over it. Let's go to triangles. What do we know about triangles?
They have 3 sides.
Yes. So triangle has 3 sides, and the way we can see it is that if we write out the name triangle, tri means 3 and angle means, does everybody know what an angle is?
Yes, sir.
Okay. So you should know what an angle is. An angle is like this part of the triangle, and it tells you stuff about the triangle. The triangle is probably, in all of these shapes, this is probably the most important shape you will ever learn. In fact, it is so important that, I don't know if you guys call it the same way as we do here, but you will take a math class called Trigonometry. So in trigonometry, tri means 3 and metry means measure. Trigonometry is an entire class of math which will be completely devoted to just learning and applying how triangles work. That's where you'll be using angles and the sides of the triangle and so forth. Also, another little word here, gon, refers to shape. So 3 shape measure, that's the entire class is about. So triangle measure. The reason why triangles are so important is that in any shape that has a flat side, so let's say you had this nightmare again, but it had this side to it, these curves would be their own little problem you'd have to work out, but you could describe this flat shape using triangles. Any questions so far?
No, sir.
No, sir.
Okay. Now, aside from triangles, squares are really important too because you use squares to define area in 2D shapes. Whilst this is true, squares don't allow you to analyze shapes the same way that triangles can. The reason why is because you can fit a triangle into any flat shape, any shape that has flat sides in it. So for example, if we have our square, we can use triangles in multiple ways to describe this square. We can say that the square is built up of 2 triangles. put together like this, or that the square is 4 triangles like this, or 8 triangles, or so forth. All of these are different angles and measurements that you can use to describe an object that, to describe an object that you're measuring. Let's say we used a hexagon. A hexagon, if you draw out the lines from each corners, can be seen as 6 triangles put together. In fact, in each shape, if you draw each shape to its sides, you can see how many triangles build up each shape, because each side of a shape represents a triangle that you can fit into it. So you can fit in 6 triangles easily in the hexagon like this. In a square, the word square, this little word QUA means 4.
Okay.
Because a square has 4 sides, you can fit 4 triangles into it, or a rectangle. And with a triangle, you can fit in triangles forever using this. But if you can see right here, a triangle is built up of 3 smaller triangles. This is the basis of what trigonometry is, where you apply triangles to flat surfaces and you can describe the whole shape by it. Any questions?
No, sir.
Okay, because if there's anything you don't understand, it's important. So in math, when you have algebra, you're adding up physical things you can see in real life. So 1 marker, 2 marker. When you multiply, you take how many things you have, and if you had 2 sets of this, it would be 4 markers. This is something that you can describe using geometry, because if everybody remembers what a number line is, and you count 1, 2 on a number line, 2 is equal to 1 plus 1. So it describes the length that you move across the number line. 1 length, 2 length. And if you were to multiply, let's say you want to multiply 2 by 1, it would be the equivalent of multiplying sides of 1 and 2. What I'm essentially trying to get at is that geometry is sort of the underlying concept that you'll be using in almost all of math. And all forms of math are just a geometric description of something. So later on, when you'll be having even like, let's use like a business example. Let's say that this described how much money you were making over some time. You would be describing this graph by how much area is under this curve and by what triangle you can make at any one point to describe how much it's increasing of this curve. Any questions?
No, sir.
No, sir.
Okay. So geometry is very important. After geometry will come trigonometry. So geo to trig. And trig is just an extension of the geometry of a triangle. And after trigonometry, for most of you, should come calculus. And calculus is just really advanced geometry based off of trig. Miss Ariel, could you mute yourself, please? Thank you. So in geometry, you are essentially learning about only really two kind of things. You're learning about triangles and you're learning about circles. Maybe you could say you're learning about squares. The reason why you're learning about triangles, which you go over in trig and other stuff, is that triangles can describe pretty much anything. Which you can see as part of your methods that you'll be using later on. And circles are simply the only real thing that, well, circles and other kinds of curves are kind of the only things that triangles cannot describe. So you have to learn about this too. Every other kind of shape is just an extension of triangles or circles in a sense. So it all comes down to flat surfaces and curves. Any questions?
No, sir.
No, sir.
Okay. This is just my way of introducing you to what math will essentially be all about and the core of what you're doing when you do all these equations. It'll just be, if you were to picture it in your head, it's just a way of applying triangles and circles to graphs and shapes in a sense. Now it is 2 o'clock roughly, or will be in about 4 minutes. Would you guys like to take a break until about 2:02?
Yes, sir.
Okay, sir.
All right, 2:02 it is. Hello. It's about 2:02. So we can continue on. So far, nobody said they've had any real questions. So I'm just assuming that everybody's understanding everything I say. Yeah. So we just talked about area before I talked about things. Does anybody know what perimeter means?
Yes, sir.
All right.
Yes, sir. The distance around a closed shape.
Okay. So perimeter describes the length around a shape. Okay. Now I use length here because length is mostly, is probably the thing you're gonna describe most of the time. When we say we have length, width, and height, that describes what dimension we tend to use, but most of the time you're just gonna say length. So when we say length around a shape, we know what a shape is. This is a shape. So if this is length around a shape, how would we find the length around this shape? Does anybody know what this shape is?
Sorry, it's a square.
Yeah, it's a square.
Length plus width times 2.
Could it be length times width?
No, length plus width.
Not
Or
quite.
length?
Oh.
Continue.
Length times length.
So length times length. So we're using times here. Now, when we say length times length, let's say this is a length because the side. What do we know about a square?
All sides are equal.
All sides are equal.
Perfect. So all sides of the square are equal. So that means this is a length, this is a length, this is a length, and this is a length. So length times length in this instance is the same thing as saying length times width. And length times width is something that we use to find the area. Now, let's think about it this way. A square centimeter is the same as a centimeter times a centimeter. That's what this is for. When we say we want to find a perimeter, we want to find the length around a shape. A length, which is what we use to describe one side. Let's say this length, we'll use this as an example. Let's say the length, is equal to 2 centimeters. If the perimeter is equal to a length, and a length would be described as a certain amount of centimeters, what should the total perimeter look like? Will it have normal centimeters, or will it have square centimeters? Can somebody tell me?
Sorry, it would be square.
Not quite, because square centimeters describe an area, and we get the area by multiplying two things together. If the perimeter is the same as a length, that means the length, since a length describes a certain amount of regular centimeters, then that means the perimeter describes the length, which describes us centimeters. So the perimeter is a centimeter amount. So it's only so it's not centimeter squared. It's just normal centimeter.
Okay, sir.
As long as you understand. So if we multiply centimeters together, we get the area of something. To maintain these normal centimeters, we can add and subtract centimeters from it. So since the perimeter describes the length, a certain amount of centimeters around the shape, so let's say all of this is the perimeter, because the perimeter is around the shape, that means the perimeter must be the length of the hole around the shape. So it's all four of these sides. Any questions?
No, sir.
Okay. So if it's the length around a whole shape, the perimeter, in a square, all four of its sides are the same, that means it would be this side and this marker's dying. And this side and this side and this side. And since these are all the same, this would be the same thing as 4 times the length. Now saying 4 times the length is different from saying a certain amount of centimeters comes a certain amount of centimeters. Because when you say a certain amount of centimeters comes a certain amount of centimeters, you're saying a length times a length. So we know that this is a length. Does anybody know what this would be called? Just the 4? Perhaps, yes, Ms. Ariel?
No, sir. I'm not sure the answer.
Okay, that's fine. So when we call a number by itself, we call a scalar. So I want you to take a note of this. This is called a scalar. And a scalar means that it's just a regular number, like 1, 2, 3, etc. Another name that we might call it is a constant, because the 4 never changes. Or in this context, we might call it a coefficient. You don't have to worry about any of these, just scalar. Now, if we look at the word scalar, I need a different marker. If we look at the word scalar, we can see that scale is in it. So when you scale something, you can make it bigger or smaller. That's what it means to scale. So if you ever saw a map and the map says is not to scale, what it means is that if you take the map as it is and you just make if you just make the map bigger, the map would perfectly show the entire area on it. That's what it means to scale. The scale does not describe a length. because the 4 is not something by itself, like how you can measure a length, but you cannot say what a 4 is. The 4 is a scalar, so the 4 just describes something that it's in front of. So let's say the L. So 4L just is the 4 describing the L. Does anybody have any questions?
No, sir.
No, sir.
Okay. So if we multiply a scalar times a length, we will get a length of 4 of the length. And the 4 in this context, it is the same as saying a certain amount of length, because it's the same thing as saying L plus L plus L plus L. So you're not multiplying a length times a length, you're saying that you're adding a length to itself 4 times. So back up to our example, if we said that the length of the square is 2 centimeters squared, and we know that the perimeter will be 4L, what is the perimeter? May I have Mr. Nathan? Mr. Nathan, since we said that our perimeter should be 4L, and we know that L is 2 square centimeters, what should our perimeter be? Mr. Nathan, are you there? Same question. Miss Delana, are you there? She is not. Mr. Aryan,
Yes, sir.
so if the length is 2 centimeters and the perimeter should be 4L, what should the perimeter be? Oh, yeah.
12.
What's 4 times 2?
4 2 8,
8.
sir.
8. Don't worry, we all make mistakes like that. 8.
I can't believe.
Is this all you said?
Yes, sir.
You're not missing anything?
Centimeter square.
No, just centimeters. I think I misspoke earlier. It's just centimeters.
Okay, sir.
So it's 8 centimeters. That describes the length of, if you were to travel across this whole square, that's how far you would have traveled. Now, there was 2 things that we could learn from what just happened. One, double check your work, because little mistakes like that, they can happen to the best of us, but the problem is that it messes up the whole thing. Another thing is to remember your units. This is extremely important. On a test in school, this might not seem like that big of a deal, because if you said that the length was 8, you would have just been able to say, oh, I meant 8 centimeters or something like that. On a test in school, this is an okay mistake to make because you just forgot a little bit. But later on in the professional field, this is very important because first off, if you just had 8 by itself, 8 doesn't mean anything. So we wouldn't know that it's 8 centimeters. We would have to attach the centimeters to it to make it mean something. That's why a scalar doesn't mean anything, because the scalar doesn't have the length attached to it to say what the scalar means. The length of 2 centimeters, the example that we use, is just a scalar describing how many of this unit of measurement is. So like it's saying on a meter stick that if you just count on the meter stick up to 47 centimeters, 47 centimeters doesn't mean anything by itself. It's because that you attach the scalar to the unit that it means that it is the length of 47 centimeters long. In other problems, when you use different units, earlier we used an example where we had a bridge that was 0.5 kilometers long, and we were trying to figure out how many planks that are 2.5 meters long. If we didn't use our units properly and we said that we divided 0.5 kilometers by 2.5 meters, that means that you would have said that you only needed 1/5 of a plank to cover the whole bridge, when in reality we figured out that it was actually 200. Another possible mistake you can make is saying that your answer was 200 meters because you didn't divide your units properly. If I said how many markers am I holding in my hand, and you said 2 centimeters or 4 centimeters, that wouldn't make any sense. And this kind of mistake happens all the time if you are not careful. So every time you are doing any math, either in your head or on your paper, we recommend doing it on paper. Because if you were to say, did what we did in the other example, 1/5, you are off by a factor of thousands. Any questions?
No, sir.
No, sir.
So since I did a lot of talking, I'm going to have you guys do a problem now. Let's see. All right, I'm going to have a hexagon. I am not going to tell you what any of the sides are. Pretend there's a perfect hexagon. I can't draw very well. Pretend I have a line going from here to here. And I said that this line was 4 meters long. I want us to find the perimeter in centimeters and the area in meters. We're going to be doing this together. So what is a way to start this off? We need to know what we're working with. Could Mr. Deo-chan, could you tell me what are we working with?
We need to add 4.
No, no adding or anything like that. I just want to know what do we have?
We're working with the pentagon.
Close enough. It's a hexagon.
Hexagon, I mean.
That's perfectly fine. So we have a hexagon. Mr. Deo-chan, what do we know about a hexagon?
It has 8 sides.
6 sides. But you're on track. Break that a little lower. Okay, thank you, Mr. Deo-chan. Ms. Delana, are you there?
Yes, sir.
Hi, Ms. Delana. What does a regular hexagon mean? So what does regular mean?
Regular. I mean, it's a regular shape.
Yes. So a regular shape. Do we know anything about regular shapes?
They're 2D.
Okay, shapes are 2D. Does regular tell us anything about the shaped sides?
Sides. They're closed.
Yes, but what I'm getting at is that because the shape is regular, that means that its sides are equal.
Okay.
Thank you, Mr. Delana. I might have accidentally not wrote a definition on the board, but I'd like you guys to just remember that a regular shape has equal sides. Okay. Does anybody have any questions so far?
Yeah, no. Yes, sir.
Okay. So far, what we know is that we have a perfect hexagon, or a regular hexagon, which means that a hexagon has 6 equal sides. Before we do any calculations, since we went over what our shape is, I also want you to look at the numbers we are given. So we are given a number of 4 meters, or a length of 4 meters. Now, can somebody read off what we're looking for? So what the problem is looking for. How about Miss Ariel? Did I recall on you?
Sorry, I can't see properly.
You can't?
If you can write a little bit bigger, that's fine.
Yes. Is that better?
I guess so.
Is it readable?
Um, I can see perimeter and area, but I can't see the other.
Okay, that's perfectly fine. Hold on for a second. So the problem is asking us for perimeter in centimeters and area in meters squared.
Okay,
So Miss Ariel, our length, meters, matches up with the units that the area is asking for in meters squared. The perimeter is asking for in centimeters. Miss Ariel, how would we figure out how many meters are in a centimeter? Or how many centimeters are in a meter?
divide them by 10, sir.
You're on the right track. So centimeters
Okay.
Centi means 100. And we know that there are 100 centimeters in a meter. So, Miss Ariel, if we know that there are 100 centimeters in a meter, how do we convert meters into centimeter?
You divide them by 100.
You're close. You multiply it by 100.
Okay, sir.
Sorry?
No, nothing.
Oh, okay. So as long as you guys know, if we have 4 meters, because there are 100 centimeters in a meter, that means 4 meters, for example, would equal 400 centimeters. All right. So we know what our shape is, and we saw what the problem, and we made sure we know what our units are. We have to then look at what the problem is asking for. The problem is asking for perimeter. Can somebody tell me what a perimeter is?
Sir, the distance around the shape.
Yes. Okay, so we know that perimeter is distance around the shape. So that should mean that if we started here on the hexagon and we were to travel all around the hexagon, the perimeter should be the distance that we traveled all around. So the other thing that the problem is asking for is area. Can anybody tell me what area is that I haven't called on so far?
Area is a space occupied in a shape.
Okay, yes. So area. So area. Goodness. is the space that the shape occupies. Okay, good. We know what area it is, and we know what perimeter is, and we know that area should be in meters squared. Very good. So now we know everything about our problem. We know what shape we are working with, a regular hexagon. So we know that we have 6 equal sides on a hexagon, and we know that what the problem is asking for in perimeter and area, and we know what our units need to be to solve the equation when it comes up. Does anybody have any questions so far?
No.
No, sir.
Okay. So now we can do some more thinking about the problem. So they gave us 4 meters, which is the length of this line that goes from one corner of the hexagon to the other corner of a hexagon. So that means it cuts the hexagon in half. Since the hexagon has flat surfaces all around it, it has flat sides all around. What do we know about shapes? We know that they're 2D, and we know that they're closed sides. But earlier we said that all shapes that have, well, all regular shapes that have flat sides like this can be broken down into triangles. Right? So with a regular shape that has a certain many sides, you can fit that many triangles into it. And that's what we found out earlier. So could somebody draw on their paper how we would fit 6 triangles into a hexagon? So it has 6 sides.
Sir, could you repeat that again?
That's fine. So we know that for any regular shape, we can fit as many sides that it has. We can fit that many triangles inside the shape. So earlier, when we had a square, because a square has 4 sides, we were able to break it into 4 different triangles like this. 1, 2, 3, 4. So on your paper, could you draw a hexagon and break it into 6 triangles, similarly to how we did this? I'm gonna wait for just a second so everybody can make an attempt. Okay, Mr. Deo-chan, do you have completed? Could you show us your work, please? Okay, thank you, Mr. Deo-chan. So Mr. Deo-chan has drawn sure. going to keep this the way it is. Mr. Deo-chan has drawn that you can split the hexagon into 6 triangles like this. Oh my God, I'm terrible at drawing. Thank you. Oh, still spotlighting you. So, Mr. Deo-chan has drawn the triangles this way, and we may notice that the way we draw the triangles throughout the hexagon is by drawing all the corners to each other in this way. So each corner gets drawn to the opposite side. And similarly to this, in our original problem, we can see that the 4-meter long line we are given is drawn from one corner to the opposite corner in the same way. Does anybody have any questions so far?
No, sir.
No, sir.
Okay. Does anybody think they have an idea on how to finish the problem from here?
Yes, sir.
Who's that? Miss Ariel?
No, sir, that wasn't me.
Who's that? Did somebody say that they knew how they can do the rest of the problem from here? I could have swore I heard someone.
Pardon me, sir, you said something just now?
Yes, I was asking if anybody thought that they could finish the problem themselves from here.
No.
Okay. So, all right, let's go forward. So we can see that the line through the hexagon is 4 meters long, and that when we broke up the hexagon into triangles, 6 triangles, they went from corner to opposite corner in the same way. So that means we know that this length is 4 meters. This length across here. So we know that this corner to opposite corner is equal to 4 meters. Does it mean anything else?
No, sir, I don't think so.
Okay. Well, if we draw the corner this way, and we have our triangles here, can we see that this line is made up of this triangle and this triangle side?
Yes, sir.
Okay. So if this line is made up of both of these triangle sides, can anybody tell me if they could figure out what the side of one of these triangles is? How about Miss Ariel? If this line is made up of the side of this triangle and the side of this triangle, could we figure out what the side of one triangle is?
Yes, sir.
Okay, so what is it? So the length is 4 meters.
Sir said me, right?
So you times 4 times 4 to get the answer?
Not quite, but you're on the right track. So let's think about the problem in a way. So we said that we have two triangles. So these are the triangles we're using. So we know that since this whole line is 4 meters, this corner to this corner of the hexagon, this line is made up of this side and this side of both triangles. So it is this side plus this side is 4 meters. So since we know this, can somebody tell me what one side would be?
Would that be 2 meters?
Yes, perfect. So that means this side would be 2 meters. So we know that the side of any of these triangles is 2 meters. So let's use this triangle for example. Since this side is 2 meters and these are perfect triangles, does that mean we would know what this side is? Anyone? So these triangles are perfect. So all their sides are the same. Since we found that the length of one triangle is 2 meters, then that means that we could also say that this side is 2 meters. Does anybody have any questions?
No,
No,
sir,
sir.
I don't have any questions.
Okay. So we know that this side, we can figure out that it is 2 meters because we figure out the side of any of these triangles is 2 meters. So now we know what the length of one of the outside sides of the hexagon is. We know that it is 2 meters. Could anybody tell me, now that we know what one of the sides of the hexagon is, how we can find either the perimeter or the area? Particularly the perimeter. Okay, so we know that the perimeter, we said, is the distance around the shape. So each of these sides together make up the perimeter of the shape. We said that this is a regular hexagon, so that it has 6 sides, and because it's a regular shape, they're equal sides. So we know that there are 6 equal sides on this hexagon, and that all the sides together make the perimeter. And we now know what one of the sides is. Can we use this information to figure out what the perimeter of the whole hexagon is? How about Mr. Nathan? Are you there, Mr. Nathan?
Sorry, sir, I didn't hear what you said.
Okay. So, Mr. Nathan, we know what one of the sides of the hexagon is now. And we know that the perimeter is the distance around the shape. In other words, yes?
No, I'm just calculating something.
Okay. So we know the distance around the shape is all the sides together. And since we said it was a regular hexagon, we know it has 6 equal sides and it's a regular shape, so that all the sides are equal. So if there are 6 equal sides and we know what one of the sides is, can we figure out the whole perimeter from it?
Yes, sir.
What is the perimeter?
12 cm. Wait, 12 meters. Sorry.
12 meters. Perfect. That's a lot. So we know that the perimeter is 12 meters. And I'm very glad that you specified meters instead of centimeters, because you kept your units proper. Thank you, Mr. Nathan.
You're welcome, sir.
Can anybody remind me what the perimeter is asking for in the problem?
It is asking to convert meters to centimeters.
Thank you, Mr. Deochan. Perfect. So since we know our perimeter is 12 meters, how can we convert 12 meters into whatever the centimeters is?
You simply times it by 100.
Perfect, because that's what we wrote up here. So 12 times 100 is 1,200 centimeters. So we know that our answer for perimeter is 1,200 centimeters. Or rather 1,200 centimeters. That's the distance around the entire hexagon. All right. So now we need to find the area. I did not tell you how to find the area of a hexagon. I'm pretty sure there's an equation for it, but you don't really need to know how to find a hexagon particularly, because as we said before in geometry, we can describe almost everything through triangles. As we have here, when we drew the hexagon as 6 triangles put together. So if we were to find the area of a triangle, could we use that to find the area of the whole hexagon? Anyone? Miss Alicia. Not there. Okay. Who have I not called in a while? How about Miss Ariel? Oh, there's Miss Alicia.
Sorry, the Wi-Fi is bad. I can't really hear you.
Okay. So The Wi-Fi, it might be bad for a lot of you. It's an issue we've been having a lot lately. So I am trying to send out recordings soon. And in that you can see what we were doing if you were missing a lot. Miss Alicia, you have bad Wi-Fi too. Who doesn't have bad Wi-Fi? Mr. No. Okay, Mr. Deo-chan, is your Wi-Fi all right? You can hear me okay?
Yes, sir, I hear you.
Okay, Mr. Deo-chan, if we have the area of one triangle, could we figure out the area of the whole hexagon?
I think so, sir.
Okay, so how would we do that? Let's pretend that we have the area. Let's say we have the area of a triangle. How do we take the area of one triangle to find the area of the whole hexagon?
If you have an area of one triangle and there are 6 triangles in a hexagon, you can simply times the area by 6.
Perfect. So you can take the area of one triangle and you can multiply it by 6 to get the area of the whole hexagon. So this is our answer. So now we just need to find the area of one triangle. I do not believe I have shown you how to do this yet. I'm going to erase this. So here's the really important equation in geometry. The area of a triangle is 1/2 base times height. Are all of you familiar with this equation? Have you guys done?
Yes, sir.
Okay. So let's say we have one of our triangles here. We know that each of the triangle side is, 2 meters. Each of the triangle side is 2 meters. When we say that we have our the sides of 2 meters, we have our base, which we would say is one of the sides here. So our base is 2. Our height would be literally how high we measure the triangle. Now, as the problem is, with what class you guys are in, I do not believe you would be able to find the height by yourself because that is a trigonometry problem. But what I can tell you this is that I will actually give you the height. So the height would be about the square root of 3. So now that I've given you the height and you know what the base is, can you do this equation, the area? Anyone?
Sorry, sir. Can you repeat that?
So, Miss Delana, so when we have our triangle, we can use one of the sides, which we found before, as our base. The area of triangle equals 1/2 base times height. We know that our base is 2 because it's just the side of the triangle. And you guys don't know the height, so I gave you the height. Square root of 3 equals height. So now that you have the base and the height, could you do the equation for me? to find the area of the triangle? Okay. So since we have our base and we have our height, our equation is area equals, Mr. Nathan, are you there?
Yes, sir.
Okay, Mr. Nathan, what is our base?
2.
Okay, so the equation is 1/2 times the base, which is 2. Mr. Nathan, do we know what our height is?
2.
Mr. Nathan, I gave you the height right here. It's the square root of 3.
I couldn't see, sir.
Oh, sorry. I wrote the height right here for you guys because as it is right now, it'd be difficult for you guys to find the height. So if our height is the square root of 3, right? It is 1/2 base times height. Our height is the square root of 3, correct?
Yes, sir.
Okay, so now we need to do the equation. Mr. Nathan, what is 1/2 times 2?
1/2 times 2.
Yes.
1/2. 1.
1. And Mr. Nathan, what is 1 times anything?
Anything.
Exactly. So 1 times anything, which in this case is square root of 3, 1 times the square root of 3 is the square root of 3. So this is our area of a single triangle. Thank you, Mr. Nathan.
You're welcome, sir.
So can anybody tell me, now that we found our area of a single triangle, how we do the rest of the equation, how we find the area of the hexagon?
You multiply.
3 times 6.
Sorry, guys. Mr. Nathan, you were on the right track. Mr. Deo-chan, did you want to add on?
I was going to say the same thing.
Okay, perfect. So we now know the area of a single triangle, and we said that the area would be what the area of the triangle is times 6. So that means the area will be the square root of 3 times 6, which is 6 square root of 3. Did anybody else have any questions?
No, sir.
No, sir.
Okay, if everybody understood, can they tell me, is this answer correct? Is the area of the hexagon 6 root 3? I'm not hearing anybody, so I am going to assume you are saying yes, unless there's internet issues. This is not correct. This does not describe an area because 6 square root of 3 is just a regular number. We said before that a number as itself is just a scalar. A scalar does not describe a length of any kind. Therefore, we are missing our units, which is in meters. So our area is meters squared, 6 root 3 meters squared. Any questions?
No, sir.
Okay, I'm not hearing any questions. I'm assuming you guys understand this. So since it is towards the end of the class, I took up some of Mr. Suresh's time on accident, so I will defer to him now.
Thank you, Robbie. You haven't taken up my time. Good afternoon, students. How are you?
Fine, thank you.
Fine,
Fine,
thank you,
thank
sir.
you.
All right, good. Is your parents available by chance at your home?
Yes, sir.
Can you move away for a couple of minutes and invite your parents to the screen? I want to have a discussion with your parents.
Okay, sir.
Thank
One
you.
moment, sir.
Take your time. Take your time. Mhm.
Sorry, sir. I'm at my cousin's house right now.
All right. So parents
All
are
right.
not there with you. All right. That's fine. You can stay there. That's okay. Let me see whichever our parents will be on.
Sir, my grandma is here.
All right. And where are your parents? Hi, Grandma. How are you?
Noon.
Good. Nathan, that's your mom. Devchan, you by your cousin. All right. Delina? Marks?
You're here, Larry. Just sorry, ignore me.
Miss Delana, are you there?
Yes, sir.
Is your parents available?
Yeah.
All right. Can you bring your parents on, whoever will be there?
Yeah, she's right here.
All right. Good enough. Thanks.
Hello?
Yes. All right. So I would assume all the parents are here excepting Devchan parents. Good afternoon, parents. How are you?
Good. Fine.
All right. I want to thank you as parents for having your children join this Zoom class here. I know you're having some challenging time.
If the parents would like to mute themselves, it would be greatly appreciated.
Karen, can you help to mute your parent system, please? The mic.
There we go. Oh, sorry, Mr. Suresh, I accidentally muted you.
Yes, parents. I want to.
There we go.
Yeah. Yes, parents, I want to thank you for joining us in the Zoom math class that where Robbie is in Maryland trying to help your children in Guyana. And this is through the Humanitarian Mission Guyana Inc. in Port Morant. It has been very challenging time for us, and I think one of our problem here is the internet right now. We have another class in the morning hours, and we don't have the problems with the internet. So I don't know if this timing is a good timing for the children when there's so much other individuals using the internet, or should we change the time with your permission to another time that will be convenient for the children and you as parents?
When you say morning, you mean Saturday morning or Sunday morning?
I don't know what we have because we have a math class, which is 5th and 6th grade, is from 9:45 to 11:30. And then Robbie comes on from 1 to 3. But it seems to me 1 to 3, I don't know the load of the internet in Guyana and if that is affecting Robbie's class for that time. So I don't know. You have to help us coming out of Guyana because I am in Florida. Robbie is in Maryland. So you got to advise us as the times that you think the internet will be good. And we can try to see if Robbie can accommodate it. I don't know. He's the teacher, yeah?
You can do it at a different time.
I personally think 1 o'clock is very convenient. Usually in the Saturday morning, parents gotta go market, children got chores to do and whatever. So the reason why students might be absent, that would be their level of commitment, not the internet.
Well, also, Christine, we have to understand, I don't know how much you were following, and there was a massive breakthrough of children not hearing and can't communicating due to the failing of the internet back and forth. I really don't know. It's not the time with us. We are good with this time at 1 o'clock. But the only thing we are trying to accommodate is a good time for the internet, not our time. Our time is okay.
Let's hear what the other parents have to say.
Parents, would you share your ideas? I don't know, we want to accommodate all the children and everybody would have an opportunity to be a part of what is happening.
Okay, well, in Delina's case, she says she has auto work, auto school work that she completes like in the morning part of the day.
Mhm.
So this time
Right.
here for 1 o'clock is very convenient for her as well.
Okay,
Okay.
okay, okay. Well, if it's 1 o'clock, we're gonna remain at 1 o'clock, but I don't
Yeah,
know what,
one is very convenient.
but I don't know what is the reception and how well would Robbie able to teach this class having a poor reception with the internet. That is our
What?
challenging right now is the internet.
Well, if it's really not working, the internet is really not working and it's disturbing the class and you have no option but to change the time,
Mhm.
that should be okay too. The children could try to work around that.
Well, that was my major concern. Our time is free. We don't have a problem with our time, neither Robbie, neither myself. But, I've been here for the past 10, 15 minutes, and some of the children is saying, sorry, I can't hear you because of the poor connection with the internet. I'm not in Guyana, and I don't know the load of the internet, and I know there's a lot of virtual classes that's been going on. But let's say,
Yes, that's the problem. A lot of
let's
kids on it at the moment.
yeah, but let's refer to our 10 o'clock class this morning with 25 students, and everybody was up and running very well. Everybody here, everybody communicate, and there was, I don't know if the time had something to do with it, I don't know.
So yeah, let's go try it at 10 o'clock and see
I
how it
don't know,
works.
as parents, is a collective effort, is a teamwork, and we want to help your children, so we want to see what is best for you and your children. I don't know the system. We can try it for 1 week more at 1 o'clock. And if it work, it work. If not, we have to adjust our sale to accommodate the kids.
Well, what you can probably maybe for next week try it at 10 to see if it works better, and then you can compare.
I don't think we can do a 10 because we already have a class at 10 on Saturday morning.
Okay, well, some other time, whatever time you think is convenient, try it at whatever time and see if it works better than it is right now.
Well, we will have to give it a shot and try to get the kids to move along because time is very important on Robbie's side, and time is also important on the children's side, of the participation and learning and be very clear with the internet, we know there is a major problem with the internet in Guyana and all the different things, but we are just trying. All right, so we'll give that a shot. And also, parents, I want to ask for your help. Classes consume at 9:45, and I think at 9:45, Robbie do a little recap. Robbie do a little recapping of whatever, and I think the class really starts.
You mean 12:45?
I'm sorry, 12:45. 12:45. Thank you for the correction. So I want you to start to talk to your children about time management. Time is very important because Robbie is in college. He's volunteering his time, and he have other things to do too. So we want to keep a very strong time management. 1 o'clock is 1 o'clock. 12:45 is 12:45. I think there's a WhatsApp group Robbie have compiled. Messages will be on that group and reminder for the classes and stuff like that. We started off with 13 children, and I think we have 5 children here right now. And I think these are the faces that have been here for the past couple of weeks.
Maybe we need to rerun that ad on Facebook, Mr. Sugrim. This maths class, the ad before the class is started. You could probably repost it a few more times. I'm sure you could capture more students.
Well,
those who missed it then.
I think this class has already gone far, and I don't want Robbie to repeat the class because of time. So these children that is already here and be participating for a couple of weeks. I don't think I will want to do that at this moment right now. Then we're going to hold back these children who is here, and then Robbie got to catch up back with the other children to where these children at. So if we have the 5 children and they're moving along and they're here every week, let's invest in these 5 children. Because if we're going to go back now, chances are Robbie got to go back and teach the class, and then it wouldn't be fair for these children who's already here. What do you think, Robbie?
Yes, that sounds generally right. Oh, bit of echo.
Unmute your mic, please. We're getting a feedback. Thanks.
So the students are doing very well right now, and the way I've been teaching it is progressive. So some of the things that we talk about in earlier classes would be very necessary to know in much later classes. So it would be a little difficult to bring in other students at the time. As of right now, we're comfortable with the amount of students that we have so far, and it seems to be working very well. And to try and maintain the quality of education I can most possibly give the students, it would be better to just stay with how it is right now. And the purpose of why we're talking about maybe moving the time to a different time is just to see if the connection is good so that the class is as good as it could be.
Thank you, Robbie. With all due fairness to the kid who is here week after week, we wouldn't like to hold them back because this class will be finished as of December 15th. We have a time frame that we're working with, and unfortunately, so maybe next year if we decided to continue, we'll be in discussion with Robbie, and that will be under tougher guidelines and rules and whatever the case may be. So I would prefer to hold on to the 5 children that we have here. And all I'm asking you parents, try to talk to them about time management, that they should be able to be here and accomplish as much as they can. As again, Robbie's in college and he, volunteering his time out of his college studies to help your children in Guyana through the missions work out here. Any question, parents?
Not at the moment.
Okay. Well, if I don't have any other question, I want to thank you, parents, and I just want to say to you, keep investing in your children. This is a wonderful opportunity that Robbie been volunteering his time to help your children. And all you got to do, make certain that your child is here and your child follow the homework and whatever is being taught, and just do whatever needs to be done.
Mr. Spanish, since not everybody could be here,
Can some of you, excuse me, Robbie, can you mute your mic? We're having a feedback, please.
Yeah. So there are some parents, such as Mr. Deo's parents, I believe, that could not be here, and some students who did not come to class today who could not get their parents onto this meeting. Would you like to say anything to address these parents?
I would like to meet with the parents and give them, whose mic is not muted? Alicia, would you mute your mic, please? We're getting a feedback. Thank you. Robbie, what I suggest you do at this time right now, I'll prefer we hold on to these 5 children, because talking to those parents and bring them back into the class, it will just hinder the success of these children in moving forward with our targeted time. And we want to finish up in December 5th. In the event we should decide to have another class next year in January, then we can take a stronger guideline in addressing those parents. This morning, I had a discussion with all the parents, and I must say it's very, very supportive group with the students and the parents with the 5th and the 6th grade. Tomorrow, I will be talking to some of the parents on the 10th and 11th grade also, because time is of essence. And you people, you parents know in Guyana, for these lessons, you got to pay. And I know that there's a very strong economic crisis in Guyana right now. And here we are giving these lessons free. There's no money or no fees that is attached to it to help your children with their exam next year. So I do hope that you will take this into deep consideration. And I really want to thank Robbie. If it hadn't been for Robbie, we at the mission level couldn't do this.
I'd like to also thank the parents who did come and were able to listen to us. And I'd like to say that your kids are all doing very well, and they're very cooperative, and I'm very grateful for them participating in the class, and for you being able to come in such short notice and talk about this with us.
All right, well, Alicia Grandma, do you have anything to say? You can unmute your... You're breaking up. We can't. That's really bad with the internet. All right. Nathan's mom, do you have anything to say?
I just want to say thank you for what you guys are doing to helping the kids.
You're welcome. I really appreciate having your feedback. Marks?
Mr. Grimm, I just want to say thank you very much for what you're doing, and I appreciate it very much. And to Sir, thank you so much for the time that you give to the kids. It's very much appreciated as well.
Well, again, we want to thank all of you. We also have the Mission Facebook page. I would like you to go back there and where that flyer is for Robbie, give your comments as parents. It will help Robbie in college also, and it will help also the mission, because we are just giving back in the gift and the form of an education and helping your children at home. So with that said in mind, I really want to thank you and thank you parents, and make sure we talk about time. 9:45, the child should all be prepared and ready to come to class with all the materials. And
At 12:45.
at 12:45, I'm sorry, I got confused, my apology. At 12:45. So I don't have anything more to say. And parents, I want to thank you so much again. Can we bring back the children on? Parents, would you step aside if you would mind? Let me have a discussion with the kid. I think Ariel is gone. Maybe they have lost signal. All right, Nathan, how are you doing, Nathan?
Fine, thank you.
Are you okay? So the class has been helpful to you?
Yes, sir.
All right, all right. So I guess you're learning a lot, right?
Yes, sir.
Good, I'm glad to hear that. Keep learning. Alicia, Alicia, are you hearing me, Alicia? Alicia?
They're muted.
Okay, okay. Alicia, she unmute back. Okay. All right, she unmute again. Delina Marks, are you there? Students?
Yes, sir.
How are you doing? How is your day?
I'm good.
Good. How was your week?
It was okay.
Very nice, very nice. So how helpful is this class to you right now?
Yeah, it's really helpful.
All right, I'm glad to hear that, and I want you to continue working and study hard. Alicia, can you unmute your mic, please? Alicia, can you unmute your mic? Good. Our internet is bad for some reason. Yeah. All right. Well, Robbie, I think that's all I have to say for now, and until we do meet again next week, and I'll be seeing you tomorrow at the class again. Thank you, kids. Have a good weekend until we meet again next week. Bye. Thank you. Be safe. Thanks.
Bye, sir. Thank you for your time.
Thank you, Mr. Nathan.
Bye.